Hey guys, this is lesson 7.1 called Add and Subtract Parts of a Whole. Our goal here is to understand that to add or subtract fractions, they must refer to parts of the same whole. Alright, so for the beginning of this lesson, you might need some colored pencils if you would like. We'll go ahead and get started. Miss Clark has the following pie pieces left over from a bake sale. She will combine the pieces so they are on the same dish. How much pie will be on the dish? So part A, it says model the problem using fraction circles. Well, in this case, if you have fraction tiles, go ahead and go grab those. Draw a picture of your model, then write the sum. Okay, so just from looking at this pie up here, we have 1, 2, 3 pieces, and it looks like there could be a total number of 6. So I draw a line there, draw a line there. So it looks like somebody ate 3 pieces of pie. Okay, so I'm going to come over down here and I'm going to shade in the pieces that we have left. Okay, so there's one, and there's one. So you got to remember with fractions that your numerator is on top and your denominator is on the bottom. Your denominator tells how many parts total that you have, okay? And your numerator tells, in this case, like how many are filled in. Okay, so let's come over here. We have 3 pieces that are filled out of how many total parts or total pieces do we have? Okay, we have a total of 6 pieces. Now if you look at this fraction, it kind of looks like similar to another fraction that you might be similar. If you look at this pie, what would you say percent of the pie has been eaten? Well, 50%, or you would say half of the pie was eaten. So another way to write that is like this. So 3/6 or 1/2 is the same fraction. It means the same thing. Okay, now we'll come over here and we have that one piece was left over. So I'm going to fill in that piece right here. Okay, so if you would look at this fraction, how many pieces are there still or filled? 1. How many pieces do we have total? 6. Okay, so we're taking a look at 3/6 plus 1/6 because we want to see how many combined pieces will make it, or when we add them together, what it's going to look like in the end. Okay, so I have 3/6, so I'm going to color in 3 from before. 1, 2, 3 out of 6. Then I'm going to add the 1/6, which is right here. Okay, so then I would have a total of 1, 2, 3, 4, 6 filled, or another way to write 4/6 is find your common number of 2. 2 times what is 4? 2. 2 times what is 6? 3. Or 2/3 of the pie is filled. So 4/6 or 2/3 of the pie is on the dish. Okay, and if you take a look at what we have for numbers here, so I'm just going to write that 3/6 plus 1/6 equals 4/6. Okay, when you're adding fractions, it's really easy if your denominators are the same. Because right now you can just go 3 plus 1 is 4, and your denominators stay the same. Later in the lesson, you're going to run into some stuff where your denominators are not the same, and so you're going to have to find some equal parts to make that work. But for now, denominators are the same, so we can just easily add straight across. Alright, part B. Suppose Miss Clark eats 2 pieces of the pie. How much pie will be left on the dish? Model the problem using fraction circles. Draw a picture of your model, then write the difference. Okay, so coming in here, we had a total of 4/6, right? 1, when we combine those other 2 together, 2, 3, 4. Okay, so we have 4/6, or 2/3 if you want to think of it like that. And then it said she ate 2 pieces of that same pie. So my drawing's not awesome, but Alright, well pretend there's 6 pieces of pie. 1, 2, 3, 4, 5, 6. Okay, and so she eats 2 of them. So I'm going to first make sure that I have the 4, 6 present. Okay, and then she ate 2, so I'm going to take 2 of those pieces away. Okay, so now I only have this piece and this piece left. So I have 2 out of 6 left. Okay, now I'm going to subtract. So I have 4, 6 minus 2, 6. And I'm going to get a total of 4 minus 2 is 2, and my denominator stays the same. So I have left 2, 6, also known as 2 has a common number. 2 times what is 2? 1. 2 times what is 6? 3. So my answer is 2, 6, or 1/3 is left. Okay, and if you take your fraction tiles just to see the difference between what 2, 6 and 1/3 looks like. So if I have a 6 piece, what's 1, 6? Here's another 1, 6, because there's 2, 6 total now. 1/3, if you put your tile right underneath it, it should equal the same. Okay? Alright, let's go on to the next page. Kevin says that when you combine 3 pieces of pie and 1 piece of pie, you'll have 4 pieces of pie. Explain how Kevin's statement is related to the equation 3 over 6 plus 1 over 6 equals 4 over 6. Okay, well we know that 3 plus 1 equals 4, right? So there's the 3 plus the 1 equals the 4. And so those numbers are your numerators. And then the equation with fraction tells us the size of the pieces. So the equation with only whole numbers does not tell us the size of the pieces. You just got to remember that those numerators are what you're adding, and since the denominators are the same in both fractions, they also stay the same in your answer. Okay. Number 2, Isabel wrote the equation 1/2 plus 1/6 equals 4/6, and Jonah wrote 3/6 plus 1/6 equals 4/6 to represent combining the pie pieces. Explain why both equations are correct. Well, remember when I told you 3, 6, and 1/2 were the same? Okay, you always have to look for those relations in the fractions. Can 3 go into 6? Yes, 3 can go into itself 1 time. 3 can go into 6 2 times. So that means that this fraction is equivalent or the same as this fraction. Okay, and then from before 1/6 comparing to this 1/6, it's the same thing. So if you were to add 1/2, which also means 3/6, you'd get the same answer as 4/6. And remember, you can also break 4/6 down as well. Okay, find a common number that the lowest number that they can go into, lowest multiple. 2 times what is 4? 2. 2 times what is 6? 3. Okay, so you can even 2/3 would be the same as 4/6. Okay, I'm going to jump down to this bottom part down here, make connections. You can only join or separate parts that refer to the same whole. Suppose Randy has 1/4 of a round cake and 1/4 of a square cake. Okay, so we have 1 filled in out of 4 parts, and then over here we also have 1 filled in out of 4 parts. Are the wholes the same? Even though you have 1/4 here and 1/4 here, they are not the same, and because the wholes are not the same size. Oops, because if you look at this one and you look at this one, this square is not the same amount as this shape right here. Okay, so no, they're not the same because they are not the same size. No, not the same size. Okay. B. Does the sum 1/4 plus 1/4 equals 2/4 make sense in this situation? No. 2/4 of the cake means that 2 pieces of the cake divide into 4 equal pieces. The circular fourth and the square fourth are not the same size because they are not part of the same size whole. So for that one, we can just put no, again, because they are not the same size. Okay. Alright, let's go on to the next page, just for some more examples here. So number 1, use the model to write the equation. And I know it's kind of hard to see on your guys' paper, so I'm going to go ahead and kind of squiggle in what they have filled in dark quickly here. Okay, so we're looking at this pie right here, and how many do we have filled in for our numerator? 1, 2, 3. And then our denominator, how many parts do we have? We have a total of 1, 2, 3, 4, 5. Okay, and I'm going to bring down my plus sign. Plus, I have 1 filled in out of 5 again. Okay, this is good because my denominators are the same. So equals, 3 plus 1 is 4. My denominator stays the same. And that's what I have here, because this piece moved over and took over this piece. So now I have 1, 2, 3, 4 out of 5 total. Okay, coming over to this one, I'm going to fill in what this has here quickly too, and all this is filled in. Okay, so this one's kind of tricky because there's a lot going on in here, but if you have to look at the triangles first, there's 1, 2, 3 big triangles, and how many of them are filled in? 2 are out of a total of 3. Okay, and then we have one that's crossed off in here. Okay, so that's going to be minus 1 out of 3 because this one's crossed out. Okay, so what we have left is the one that's untouched here. 2 minus 1 is 1, and our denominators stay the same as 3. Okay, this one over here, this is going to be an adding one. We have 1 out of 4. 1/4 plus 1 out of 4, 1/4 equals, we have 2 filled in out of 4 total, also known as the fraction what? If I draw this line here, I hope you can see that 1/2 is filled and 1/2 isn't, so 2/4 is the same as the fraction 1/2. Okay, those are equivalent fractions. Okay, number 4. See, this is where I'm talking about your tiles. It's really nice if you can't remember which fraction's bigger, you're trying to compare the two, line those fractions up. Oh, what do I got going on over here? Okay, alright, so for this one, I have a total of how many 8s filled in? I have 1, 2, 3, 4, 5 out of a total of 6, 7, 8. So I have 5 filled in out of a total of 8 boxes. Okay, and then it looks like I'm crossing out 3 of those. So I'm going to subtract 3 8s. Okay, so 5 minus 3 is 2, and my bottom number stays the same, which is an 8. So also finding those common multiples between 2 and 8, 2 can go into itself 1 time, and then 2 can go into 8 4 times, because 2 times 1 is 2, and then 2 times 4 is 8. Okay, so we have 1/4 also means the same as 2 8s. Okay, coming down here, 3/4 minus 1/4. By now you can kind of tell 3 minus 4 is 2/4. Also, we just learned over here that, or somewhere maybe, I thought we did, 2/4 is also the same as 1/2. Okay, because 2 can go into itself 1 time, and then 2 can go into 4 2 times. Okay, coming down here, got a wacky pen today. 5 6 plus 1 6, so 5 plus 1 is 6 out of 6. Now I don't know if we've talked much about this one, but whenever you have a fraction and it's the same number as your top and your bottom, that's just saying that if here we have 5 6, then we add that 1 6 together. Now we have one whole completed. So 6 out of 6 pieces filled also means the same as one whole. Okay? Alright, I hope that's enough examples for you guys. I want you guys, the assignment is on Schoology, and then please probably do all of the back problems for good review. Alright, thanks guys. Have a good rest of your day.